I go to like the statistics on the calculator
Yep.
and then go to one variable?
Yep.
Do I then need to like put in the numbers and then how frequently they come up?
Yep. And I probably wouldn't even bother with frequency. Just say the frequency is one for everything.
I think 15's got two or three.
So I'd probably just put in 15, 15, something like that,
Okay.
because they're not in order.
Yeah. And sorry, how did I press like equals when I put the numbers in?
Then you press option.
Option. Okay. And then one variable calc.
Mm-hmm.
So the median is 16.
Median is 16 and lower quartile.
Will that just be 8?
Uh, what does it say? Q1.
So you want it says 14.
Does your one not say 14?
No, no, sorry, mine says 14. Sorry.
Okay, so we think 14 and 16. 16 and 14. That's it. And so, any questions there?
No.
Okay, so now this harder one. How about this?
So do I need to now take the middle from each time wasted thing
Yeah,
and then put it into the calculator?
yeah. So option data. Make sure you delete your other stuff.
So what's the mean like the thing with the x, like the line on top?
Mm-hmm. X bar.
So yeah, I got the same answer, 43.979.
So I'll just say that's 44.0 roughly.
Yeah.
And B.
So is this where I have to use some sort of formula or something?
Yep. I mean,
Um,
it was a tricky one.
yeah, I'm not quite sure.
So you would start by doing 0.65 times the total frequency.
Yep.
And so what do you get for that? So we go back to normal mode. Okay, so whatever the total frequency is times 65% is 31.85. And so that means it's the 31.85th value. So the way I do it is in terms of x. So we're trying to find, so our 44.0 for the previous one was one of these t up here. So we'll start with our x. I'll just call it p65. What group will the 31.85th value be in?
The 30 to 40.
Nope. That only goes up to the 16th.
Oh, sorry. The 31.85. So 16, 18. The 40 to 50. Sorry.
Yeah. And so basically, that fraction into that group, so it's some time, take away 40 out of 10 minutes, 50 minus 40. That will be equal to, we said it was the 65th one. It will be 65 take away 16 plus sorry, that's it. What was it? 31.85. 31.85 take away 16 out of 18.
Okay. Yeah. Okay. I'll put that into my calculator then.
Yeah.
Sorry. How do I write that P65 thing in?
So just use X.
Okay.
Maybe I should just use X.
Yeah. So I got X is 48.8.
So 48.8 minutes. So our part A, our estimate was 44 minutes for the mean, and then part B, our 65th percentile, which should be a bit more, it's 48.4, and part C,
Sorry, it's 48.8. Sorry.
48.8 was it?
Yeah.
Okay.
So if we, so the frequency added up is 65, isn't it?
I don't know.
No, it's 49. Sorry.
So total frequency is 49.
So you have to do 49 times 10%. The frequency to
I think that would be towards the bottom 10%. I think for this one you'd find the 90th percentile. So P90.
okay. So I need to do 49 times 0.9.
You'd have to do what we just did, but for the 90th percentile. So you start by doing 0.9 times, 90% of 49 to begin with.
Okay, I got 44.1.
Okay, what's next?
Um,
And so you can use what we did before. So we did x minus the lower bound over class width.
I'm guessing I need to replace the 44.1 with one of the numbers, don't for the formula.
Yeah.
Hmm. Wait, do I have to do 44.1 instead of 31.85?
Yeah.
Okay. Yeah, it gave me 48.8.
Hold on. So you did 0.9 times 49.
Oh, no. I wrote in 31.85. Sorry, my bad.
What was it, sorry?
Sorry, I'd written it in wrong.
Oh, okay.
I got 55.611. So 55.6 basically.
55.6. So let's round that to 56.
Yeah.
56 minutes. And so only 10% of our customers have to wait longer than 56 minutes?
So yeah, that probably is true there.
So yeah, it is. Yeah, so 90% have to wait like 56 or less. And so top 10% more than 56. 90th percentile is 57.8, they're saying. Hang on. Let's see. So what was your... What working out did you do for this one?
I did x minus 40 over 10.
What group does it go into? The 44 point first value.
Probably the 50 to 60.
Why are you saying probably?
It will be 50 to 60.
I don't know. 10 plus 18. So that goes, cumulative frequency is 34. That is going to be 47. And that's 49. So we did 44. So it's 50 to 60. Okay. So you're in the 50 to 60 group.
Yeah.
So what do you do there?
Does that mean I need to take away the midpoint of... I'm all a bit confused, honestly.
So it's going to be the fraction that x is into that group. So x is a time in minutes. So x minus 50.
Yeah.
Out of 60 minus 50. So basically out of 10. So if it was like, if they're saying it's 56 minutes, so you could do 56 minus 50 out of 10. So that would be like 6 out of 10. So they're saying it would be 6/10 of the way into that group.
Yeah.
So 6/10 of the way into that group, and that would be the same as 44.1. So that's the frequency. So 44.1 minus the frequency up to that point, which was 34, out of those 13 people. Yeah.
Okay.
So solve. So we get 57.8. So let's. So what would. So comment on that thing there.
That would be more like 58 people. 58 minutes. 58 minutes.
Yeah, so that is 58 minutes. So no, they have to be 58 minutes or more.
Yeah.
Minutes. Let's come up with our thing. So it is basically if we go back to our previous one, so it's x minus the lower bound out of the class width.
Yeah.
So it's like that fraction that x is into that group is equal to the value or the position. So like median position or lower quartile position minus not quite sure how you'd say it. So the cumulative frequency up to that point. So cumulative frequency over frequency. Maybe that's how you'd say it. So it's like what you do in terms of the top group with x is what you do with the bottom group in terms of frequency. So it's like this fraction is equal to this fraction. There's an easier way with a diagram. No, there's not even easier. There's just no easy way to do it. All right, so that's kind of a formula. We just need to try it. Okay, linear interpolation median. This one.
So I can use my calculator, can't
I? How that would be. So what would you put into your calculator?
I just put like the midpoint of all the masses and stuff like.
So that would give you an estimate for the median, but that would not be using linear interpolation. That would just be using like a very simple estimate.
Yeah.
So I'll do that, and we'll just compare our answer at the end. And so, what else? How can you do linear interpolation?
Would I have to add up all the frequencies and then divide that by 2?
Yep, because it's median.
So that would be. So if I did 36 divided by 2, would that give me the median?
That would give you the position of the median, yeah.
Yeah, sorry. And then, so if it's in the 18th position, so that's like the first one after in the 50 to 55 group.
Yep. So it's in that group. And so I would start with x.
Okay. So is this where I have to use the formula?
Mm-hmm.
So x minus.
Mm-hmm.
Is the lower bound just going to be like a quarter of 36?
X isn't a frequency; it'll be a mass.
Sorry. Will the lower bound be a quarter of 36?
36 is a frequency. Our X will be a mass.
Okay.
What is the lower bound of the mass?
50.
Yeah, so we know that if it's in that group, then we know it can't be less than 50.
Yeah.
And it'll probably be pretty close to 50 if it's the first in that group.
Oh, at the bottom, minus 55 minus 50.
Yeah.
And then here, position, do I need to just put like 30, oh no, 18
Mm-hmm.
minus, I have to do the cumulative frequency thing now, don't I?
Yeah, but just up to that point.
So will it just be 17?
Yeah.
Over 14.
Yeah. So basically it's 1/14 of the way in to that group. And okay, solve that one.
Okay. I got 50.35, so 50.4.
50.4.
Yeah.
So that is 50.4 minutes. And explain why it's just an estimate.
Because there's varying different methods.
I'd probably say because the data is grouped.
Okay.
So it's not raw data, it's grouped data. So it's like 14 are between, 50 and 55. You don't know exactly the weight of each group, like of each thing. It is assumed that the frequency in each class is evenly distributed throughout the interval. So they're saying, you just assume that they're evenly distributed. Yeah. Okay. That like these 14, that like the first is very close to 50, the last is very close to 55, and each one is an even, steps all the way through. Any questions there?
No.
Okay. So X minus 50 out of 5. 18 minus 17 out of 14. Yeah. Okay, 80th percentile.
Okay.
And actually, we said our rough estimate was 52.5 using our midway thing.
Yeah.
So it just picked the middle value, 52.5, but our better value is 50.4. And we knew if it's only 1/14 of the way into that group, 1/14 of that. Let me just see. So then using my older method, 1/14 times 5, the class width, and then we're starting from 50 is that same number. Yeah. Okay. Okay, let's try this.
Okay. So if I find the cumulative frequency here, so it'll be 424. And then 61, 89, and yeah.
Okay.
The 80th percentile will be in the 2 to 2.5 group.
Mm-hmm.
So does that mean I now need to do for the formula thing?
Yeah.
X minus 2.5
Mm-hmm.
Over 3 minus 2.5
Mm-hmm.
is equals to position. Just 89.
No, we never actually found the. Wait, well, you don't really need to. It's out of 100, I suppose. It's not 89 though.
Sorry, I thought it was going to be in the other group. I thought it was going to be the 2 to 2.5 group.
So that's the first 61 things are in there.
So anything after that will be in the next group, basically.
So if we're looking for, so you kind of skipped something. What we usually do is 80% of 100.
Right.
But what is 80% of 100?
80.
Yeah, I think that's why I skipped it, because it's.
So its position is going to be 80.
Yeah.
Minus 89.
Yeah.
Over 28.
Yeah.
Yeah, I got 2.33 or 2.34. Sorry.
Something's not right then. We're saying it's the 80th thing. That means it has to start from 2. The lowest it can be is 2.5. Like, it's in this group somewhere. So like this group is from the 62nd bird to the 89th bird. So if it's bird 80, then it has to be in here somewhere. This is wrong. 80 minus 89. That's a negative number. This 89 is wrong. That's what it is. It's 80 up to that point. That should be 61.
Okay.
Yes. That's what it should be. Try that.
Yeah, I've got 2.84 now.
2.84 meters. And okay, how about B?
Is it just because you don't have a number for W?
Yes, there's no upper bound there, and so we don't know what it could go up to. Like it could go up to 10, could go up to 100. We don't know. So 2.84. The 90th percentile is in this class. There is no upper bound for this class, so it is not possible to estimate 90th percentile. Any questions there?
No.
Okay. Are these worth doing? These are similar.
Yeah, probably. I think yeah.
Okay.
So for medium length, do I have to add up the frequencies and divide it by 2?
Yep.
And I got 41.
Okay. And what is next?
So I need to use the formula.
Yep.
So x minus 30
Yep.
over 35 minus 30
Mm-hmm.
is equals to the position is not 53, is it?
No. That's the end frequency.
Will it be 41 again?
Yeah.
Yeah. Minus 53.
It's a negative number.
So will it be 25?
Yeah.
Over 28.
That's it.
Okay.
So we get 32.9. And how about A part 2?
Do I need to do 0.7 times 82?
Yeah.
I've got 57.4.
Okay.
And so for the formula thing, do I then need to do x? Oh, yeah.
Yeah. X.
Sorry. X minus 35.
It's gonna be in that group. Yeah.
Over 40 minus 35.
Mm-hmm.
Equals to 57.4
Mm-hmm.
minus 53
Uh-huh.
over 17.
Yeah. Solve. And we say 36.3. So the first one, so it got a bit bigger. Let's see. So first one was 32.9, and that was the median, and that was centimeters. 32.9 centimeters. This is their length. And so the 70th percentile, you'd expect it to be a bit longer, and it is 36.3 centimeters. And then I think you're okay for B, 32.9, 36.3. Great. And this one had no upper bound. Any questions there? I think you've got those. Am I right in saying you'd be fine for A?
Yeah.
Yeah. Then how do you go about question C? Or sorry, what would be question B?
Partly. But would I need part A to get to part B, or?
No, it's just something you use every single time. They may not be aware of.
No, I'm not aware of it.
The times are evenly distributed. So what that means is they're not like clustered, like they're not all like all 6. You could say all 6 were 2 minutes. That would be the old way. Now we're actually saying they're evenly distributed. So those 6, like there's one in the middle, there's 2, then there's maybe 1.25, 1.75, something like that. So they're kind of evenly distributed. And C. How would you go about that?
So would I need to do 20% of all the frequencies added up?
I just want to see the station. So basically, my thinking was you would do it with P20, so 20th percentile. So the station advertises that fewer than 20% of trains are delayed by more than 8 minutes. So 8 minutes would be up here. The lengths of train delays are recorded in this one. The station advertises fewer than 20% are delayed by more than 8 minutes. So maybe you have to find the 80th percentile because it's more than. Let me check. Yes, you'd have to find the 80th percentile for that one. So it seemed like it was going to be the 20th percentile, but it was actually the top 20%, so 80%. Okay. Any questions there?
No.
Okay. So that stuff, what do you give yourself?
I'll say like 0.75.
Hey, I'm happy with that. That's a tricky one. Okay, measures of spread. So now they go back to being pretty easy. How do you find interquartile range?
That's just the upper quartile minus the lower quartile.
Yep. And a minute ago we were finding upper quartile using our method 0.75 times a thing and lower quartile 0.25 times it. And so we will be using our formula twice. Once for upper quartile, once for lower quartile. So it's like the same as 75th percentile minus 25th percentile. And you do it that way. Okay, let's try this. How would you do this?
So the range is the difference between like the largest and smallest number.
Mm-hmm.
Do I need to like times out the midpoint of the mass times the frequency? Or...
I don't think so. So that's one way to do it. No. What's the heaviest one of the elephants can be?
6.5 tons.
Yeah. What's the lightest it could be?
4 tons.
How could you find range?
Oh, just 6.5 minus 4.
I think so. And so it goes up to 6.5, so we use that as a boundary. And you could also kind of estimate it to be like all of them are 6.25. But if I was going for range, I might just say that. So that's 2.5 tons.
Yeah.
Okay, how about B?
So here I need to... I can just put this into my calculator and then just subtract the upper quartile from the lower quartile.
So in this case, I believe so, because they didn't say using linear interpolation. So we could use a simpler estimate, which would just be the midpoint, which is just the calculator. And so how would you do C?
Does that mean I need to do like 90th percentile and 10th percentile and some subtracting from each other?
Yep, let's try it.
So I need to add up all the frequencies and times that by 0.9.
Yep.
So that'll be 108.
108, okay.
So do I need to do 108 minus no, sorry. Would it be x minus x minus 6
Okay.
over 6 minus 5.5. Oh no, sorry. over 6.5 minus 6
Mm-hmm.
is equals to 108
Mm-hmm.
minus 101 over 19.
Yep.
And then, yeah, I think, yeah.
And we get 6.18 tons for that one. Oops. Is that full marks?
Do you think it's going to 10th or no?
Yep.
And then do I need to do 120 times 0.1?
Yep.
So that'll be 12.
Yep.
So will it be x minus 4
Mm-hmm.
over 4.5 minus 4 is equals to 12 minus would I have to say something like 0
Yeah. So it's just 12 out of.
over 13.
Yeah. So it's 12/13ths of the way into that group. And then we solve that. And we get 4.4615 tons. Okay.
And so if I subtract those from each other,
Let's say to 3 sig fig.
so 1.72.
So that's 1.72 tons. 2 tons, and that's the range. 1.72 tons. Great. So it's just. So let's see. So range was, yeah, so they took 6.5 minus 4.0. So upper bound of the heaviest group minus lower bound of the first group. Q1. So let's see. The B. So I think this question is an example question, and so they didn't word it very carefully. They need to say using linear interpolation. So for B, they didn't say using linear interpolation, but it looks like their answer they wanted you to do that. But C, no two ways about it. You have to do that, and it's just P90 minus P10. Any questions there?
No.
Okay, so let's just see. Do you think? Oh, let me go back for a second. What is this? So we got our estimate was 1.7. So P10 to P90. How many elephants are roughly between the 10th to 90th percentile? How could we do that?
So if our answer is 1.7, would we just do 0.9 times 120 and 0.1 times 120 and then subtract them from each other?
Yeah. And
So
you did 0.9 times 120 and you got 108.
Yeah.
And you did 0.1 times 120 and you got 12.
So 108 minus 12.
I believe so. Let's see. So, how would you do that same thing for this one? The number of elephants between the 34 and 66th into percentile range.
But I'll just do.
Sorry, the income elephants.
So if I got the cumulative frequencies,
So 70 goes up to, I think.
so if I just did 17 times 0.66.
70.
Oh, sorry. Yeah, 70 times 0.66 minus 0.34 times 70. And I got a 22.4.
22.4 pound. £22.40.
Yeah.
What is this? So is it measured in anything? Okay, £22.40. So, 22 data values. So, no. So 22.4. So that's roughly 22 data values. The number of data values that fall within this range. So it's like 22 workers roughly are in between that range. Yeah. Okay, I think you're good. And then the first bit was just P66 minus P34, which I think you're okay for.
Yeah.
So it takes a long time. It's a bit tricky, but it's the same thing. This one looks the same. I think you're gonna be good. Same two things. So this one here is not grouped data. How would you get into? How would you do part A?
Would I be able to still use the formula, or probably not?
The formula is for grouped data. It's a way to estimate the median.
Yeah. Here, can I just put them into my calculator?
I believe so. Yeah. And it's important that we do that for part B. So this time it's like raw data.
Yeah.
And so we know that everything won't be an estimate. It'll just be the actual thing. Or you could do GCSE, smallest to biggest.
Yeah.
Cross out first, cross out last.
So, I got median 11.5, and for interquartile range, that would be 12.7 minus 10.3, which is 3.4.
Okay. And part B.
Okay, so would you say something like, on average, June was hotter? No, the first 10 days of June were hotter than May. Would you then also say something like, June. Oh no, and then would you say that May had a more like various like temperature, like more various temperatures,
Yeah.
whilst like more consistent and stuff.
Uh, yeah. So, and to do it the other way, so we talked about June for the first one. So, on average, June was hotter than May, and there was less variety in the temperatures in June, or yeah, more variety in temperatures in May. Yep. And everything else is fine. Any questions about that?
No.
And more consistently hot. I'll just summarize. On average, the temperature was higher in June than in May, as the median is higher. However, the temperature was more variable in May than in June, as the interquartile range is higher. Yes, that word, however. Oh, okay, I suppose. Let's see. Median and interquartile range. Compare. You're good. How would you estimate the range for this?
I'd print my calculator.
Not interquartile range. Range.
Oh, I'd just do 500 minus 400.
Yeah, and B.
Maybe because um there may not be any kittens that weigh 400 grams or 500 grams or something.
Yeah, I might say like it's grouped data, not raw data, so we don't know exactly.
Yeah.
Group data, not raw. And then C and D, you're good for. It will be less than this, as it is unlikely that there is a value of 400 and there cannot be a value of 500. So I was thinking that as well. It goes up to 500 but doesn't include it. There you go. And 90% of customers weigh between 2 and 4 cost of suitable percentiles comment on the validity of the company's claim. Let me read this. Weight between 2 and 16. Okay, how would you start this one?
So yeah. So you need to do 90% of the cumulative frequency.
So 83 and then 100. But the company claims that 90% of customers wait between 2 and 16 minutes. We have to kind of work in reverse for this. They tell us 2 and 16 minutes because it's not the 90th percentile, it's the middle 90. Like there's 90, not necessarily middle, but there's 90 between it.
Yeah.
16 and 2. So any idea how you do that one?
Would you do 10% of 100?
No, we have to work in reverse for this one. They've told us the minutes.
So do I do 90% of 2 and 90% of 16? Or
No.
I'm not sure.
What they're saying is from 16 here to like 2 in there is 90%. So it's like we have to work in reverse. What percentile is 16 using cumulative frequency?
83%.
So, what percentile? Estimate what percentile would be 2 minutes.
3.
So I think that's how you'd do it. You do the 83rd percentile minus the 3rd percentile, and you'd see if you get 90% of the customers. So there's 100 customers, so you should get 90. I think the 5th and 95th percentiles, and that's the company's understanding. 5th and 95th. Oh no, that's silly. So 5th and 95th. So I suppose this only gives 80%. They really didn't word that clearly.
Yeah.
So 90%. The company claims 90% weight between two. So they need to say, so it could be 0 to 90. They went with 5 to 95. They could go 10 to 100. So what they tend to do, what seems to be an unspoken thing, is it has to be the same either side. So 5% at the bottom and then 5% at the top. And that's why it's 90% in the middle. Okay, so that's an unspoken thing. Anyway, hopefully no exam question would have that. Measures of spread.
I think maybe a tick.
And I think because you did the other stuff so well, that then you were able to do that stuff much easier. So let's take a look. This was the stuff we did last time. Mean median mode wasn't too bad. And then we just practiced it this time. This will load in a second. Okay, so where possible, raw data, use calculator.
Yeah.
Excuse me. Grouped data, if they want the mean, calculator will work. If they want interpolation, so estimate median, low quartile, upper quartile, or any percentile, use our formula. So it's like this fraction of the x is equal to that fraction of the frequency.
Yeah.
And then you solve. So that gives you two true statements that are equal to each other. So you can use that to solve. Yes, you can't get an estimate if you don't know the upper bound. That seems to be a common thing they do there. This one, yes, watch out for this type. So they were saying 20% more than 8 minutes. So we had to find the 80th percentile. So it's like those cumulative frequency questions from GCSE where you have to say how much is more, not less. Yes, interquartile range. Just do P75 minus P25. They like to do other stuff. Yeah, 10 to 90. So 10 below, 10 above. So it has to be the same either side. This one, estimate the number of data values that fall in there. Yep, that's okay. Range, biggest minus smallest. Hang on, what was this one? The number of data values that fall. Yeah, so 66% minus 34% of the total. Yeah. And then other than that, yeah, comparing averages. You remember that from GCSE. That's good. And then it's grouped data, not raw. Yes, and the other thing we assume is that these are evenly distributed. So they're not all clustered in the middle. That's the assumption that we make for these. How was that for you, Andrey?
That was good, thank you.
Okay, so what we've been doing is like averages. So essentially mean, median, and mode. And then next would be new types of spread. So before, the spread you're used to is range, and then a better one is interquartile range. And you'll do other stuff like variance and standard deviation, which are like the spread that match up with the mean.
Yeah.
How does that sound?
Yeah, that sounds good, thank you.
Okay, and I'll send you those things ahead of time. Any questions for me in general?
I don't think so.
Okay, well done, Andrey. You did great. I look forward to telling you again next time.
Yeah, thank you. Bye.
Have a good one. Goodbye.